This is the first video in the Space Weather Basics series. In this video, we will look at the basics behind coronal mass ejections, Earth's magnetosphere, and auroras. The videos that follow in this series will give a more in-depth look at each of the areas. Let's begin. Coronal mass ejections. Coronal mass ejections are produced from sunspots and solar flares. A sunspot is an area of the sun with charged and twisted magnetic fields. When these areas of built-up energy are released, they create a solar flare or coronal mass ejection. When these charged particles are ejected from the sun, they can take anywhere from a few hours to a few days to reach the Earth. The Earth is protected from these charged particles by the magnetosphere. Earth's magnetosphere. As seen here in this cross-section of the Earth, the Earth's magnetosphere is formed deep within the Earth, in the inner core. Earth's inner core is made up of mostly iron. As the core rotates, it produces a magnetic field that surrounds the planet. This magnetic force field protects the Earth from solar radiation. As we have just learned, the Earth's magnetosphere is produced by the rotation of Earth's inner core. The magnetic force field that is produced extends from the north and south poles. The poles are where the magnetosphere is at its weakest. When strong winds or coronal mass ejections come in contact with Earth's magnetosphere, it causes the magnetosphere to be stretched and pulled. When the magnetosphere snaps back to its original form, this creates auroras at the poles. The solar winds and coronal mass ejections that come in contact with the Earth also have the ability to disrupt electronic devices on the ground and satellites in space. Auroras. Auroras are a natural phenomenon that occurs when the magnetosphere is bombarded or interacts with charged particles from the sun. Typically, auroras only occur in high-latitude pole areas around the northern and southern poles. Depending on the strength of the solar flare, auroras can be a variety of colors, including green, red, blue, yellow, or purple. We will look at the reason for these various colors in a later video. When strong storms impact the Earth, auroras can be seen as far south as Massachusetts and as far north as southern Australia. Typically, when a solar storm of that magnitude impacts the Earth, scientists, engineers, and satellite operators from governments and various companies often shut down spacecraft and satellite to avoid potential damage. What have we learned? We have learned about a new type of weather called space weather. Space weather is produced from the sun in areas called sunspots. Sunspots are areas on the sun of charged magnetic fields. When these magnetic fields are released, they produce solar flares or coronal mass ejections. Coronal mass ejections are large clouds of radioactive particles that can take anywhere from a few hours to a few days to reach the Earth. When they reach the Earth is protected by a magnetic force field called the magnetosphere. The magnetosphere is a magnetic field that surrounds the Earth and protects the Earth from these charged particles. When charged particles interact with the Earth's magnetosphere, they produce auroras in the northern and southern poles. These auroras vary in color, duration, and latitude depending on the strength of the coronal mass ejection. What is next? The next videos in this series will look at the Earth's magnetosphere in more detail, looking at how it is produced, what its weaknesses, and its overall shape. We will also look at the sun in more detail. We will look at the corona, the photosphere, and a more detailed look at the sunspots. Also, we will focus on NASA missions that are aimed at learning more about the sun. These missions include the SOHO project, SDO satellite, and the IRIS satellite, which was launched in June of 2013.